it on my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to be talking about how to generate random values in Python, as well as just randomness in general. But before we get into how you can generate random values in Python, we need to talk a little bit about what is randomness. Well, randomness usually refers to the lack of a pattern or predictability in events. Usually when we're talking about randomness, we talk about true randomness that occurs in natural processes, such as coin flips, dice rolls, and even things like radioactive decay. But how do we generate a random number on a computer? Computers are very deterministic. That means we can do a bunch of different mathematical operations, but if we do them on the same values and in the same order, we're going to get the same results. So how can we actually turn that into a random number? What sort of mathematical operations could we possibly do that would have a different result each time, that would be random and unpredictable? Well, one approach that we do see is using specialized hardware. And back in the day, these used to be somewhat elaborate machines. For example, there used to be a site called Games by Email that would allow players to play different games through email addresses by sending messages back and forth. And the way they would generate random numbers for their games was with a machine they call the Dice-O-Matic, which actually rolled dice for them and then computed the results. Here we see right now an example of that machine run. And you can see that it's constantly rolling dice. They're going down this nice little chute. When these dice reach the bottom, they get into a little elevator, and then they go up that elevator in nice rows. So it sort of lines them up nicely. And then when they get to the top, there's a camera and a light that would read the values on those dice, and then use that to actually generate random numbers for the games people are playing through this website and through their email accounts. Now, there's a lot of problems with machines like this. In this case, you can even hear it. It's quite loud, big, cumbersome, and it's probably going to break down quite a lot with all these moving parts. And here we can see the scanner actually scanning the different dice and determining a different value for each one based on the face of the dice that's showing. Another approach that's been used by companies in real life are to put webcams on big walls of lava lamps and then generate random numbers from this based on the way different wax forms and moves. And there's an interesting video you can watch on this about a company that's using this to make cryptographically secure random numbers that they use for things like encryption. So specialized hardware like this is an option for creating random numbers. And they do make chips now that are able to make random numbers that are hard enough to predict that they are considered to be cryptographically secure, which means that we could use them for encryption purposes, such as creating random keys for our encryption. Now, it does raise the question a little bit though, is anything truly random? Are those lava lamps actually bubbling up in a random way? And is that dice throw that the Dice-O-Matic's making actually random? If we knew enough about the environment, the conditions that the dice is currently in, and the exact dynamics of the dice, could we predict what that dice throw would be? And there has been some research into this. Right now we can see a picture from a paper called The Three-Dimensional Dynamics of the Die Throw. What they did is they created a device to very controllably roll a dice over and over again, and they were able to model with high accuracy and be able to predict what that dice throw would be, as well as the probability of it landing on each side. Their summary was, to summarize, the die throw is neither random nor chaotic. We show that the probability that a die lands on the face, which is the lowest, is larger than any other face. That is, dice are not fair by their dynamics. So that raises some questions. If even things like the Dice-O-Matic aren't truly random, how can we create random numbers on a computer? I mean, we don't think we want to have a big wall of lava lamps if we just want to make some random numbers to play like a poker game on our computer, to draw different cards, or even something like Minecraft that just controls the mobs walking in different ways or how the world is generated differently. So how do we get those random numbers without specialized hardware? And the answer is we fake it. And the way we fake it is with a pseudo-random number generator. So these custom hardware-based solutions aren't practical. So in most cases, when security doesn't matter, like we're not generating something to be used in encryption, pseudo-random number generators, or PRNG, are used. And these are algorithms that generate sequence of numbers that have the properties of random numbers. So they're not truly random. By pseudo-random, we mean sort of like fake random. But to an observer that's doing some statistics on these numbers, they seem to exhibit the properties of random numbers. And one of those properties is usually that the numbers are uniformly distributed between a minimum and maximum number. So if you're generating numbers between 1 and 10 inclusive, you should have the exact same likelihood as a 1 showing up, as a 2, as a 3, as a 4, and so on, all the way up to 10. And if you were to plot out a histogram of those, you should see a nice straight line with each number occurring as much as the last one. So how do pseudo-random number generators actually work? Well, that question's a little bit out of the scope of the course, and we're not going to dive into making your own PRNG. But if you are interested in that topic, there's a great video here that I linked to in the slides, as well as the video resources that goes more in depth into this and explains how you can make your own PRNG. But the main thing is that however the PRNG works is it has to return numbers that have certain properties of random numbers. What are these properties? Well, we already covered one. They have to be uniformly distributed. That means the numbers generated should be spread out evenly across a range. That means every single number should have the same probability as showing up and should occur the same number of times. If we were to plot it out, we get a nice line, which we could see about every number occurring the same amount of times. Next is the PRNG should have a long period. By period, we mean how long the sequence goes before repeating. We don't want the PRNG to be producing numbers that repeat or have some pattern that makes it really clear what the next one's going to be. So usually we want to make sure, however we have it configured, that it's going to go a very long time before the sequence of numbers starts repeating again. And lastly, it should have efficiency. It should be fast enough that if we need to generate a ton of random numbers, it can do so very fast. For example, simulations in games are usually creating thousands of random numbers at a time, and we don't want to bog down the computer with trying to generate each one. Another important property of a PRNG is the seed value. A seed value is a particular value, usually an integer value, that initializes the PRNG and determines the sequence of random numbers it will produce. If a PRNG is given the same seed value, let's say 5, it will always produce the same sequence of random numbers. So if we give it a 5, it will always produce maybe a 1, then a 6, then an 8, then a 3, then a 2, and it will always produce them in that order given the same initial seed. Now, that might seem a little bit odd. We're trying to make random numbers after all. Why would we have a seed value that makes them deterministic? Well, there's a few reasons. The first one is reproducibility. In simulations, experiments, or tests, you may want to be able to reproduce the same results of your program given the same values. So by having a seed value, we can control what that random sequence will be, and we'll get consistent results. Another reason is for debugging purposes. If your program has random behaviors based on some random numbers it generates, then it's going to be really hard to debug because you're not going to get consistent results. It could make it really hard to reproduce that bug and track it down. So by being able to manually override a seed value and force your program to be more deterministic, that means it's easier to debug. So having a seed can be very useful for a PRNG. And there are ways around making it so that you get the same result each time. We can set the seed, for example, to the current time when the program started, and that means we'll get a different series of random numbers every time that program's run. So what might this look like? Well, let's say we have a PRNG that generates random numbers between 1 and 10, and we tell it to make 10 random integers. And we're going to set the seed to 1. Well, we might get an output that looks something like this. 3, 10, 2, 5, 2, 8, 8, 8, 7, and each time we called the PRNG, we'd get a different number. And all of these numbers, if we were to plot them out, would be just as likely to occur as the next one. So there'd be the same number of 8s as 2s as 5s, 10s, and so on, as long as we generated a large enough sample size. And if we set the seed to something else, like 42, we would get a completely different series of random numbers. But if the seed was the same, like we kept it at 1, we would always get the same series over and over again. So we have a way of controlling what order those random numbers are going to occur in. And again, we could make that more random by setting it to something like the system time, so it's not as predictable. It won't be the same every time it runs. So why does this all matter? Why do computers need random numbers? Well, we already mentioned one scenario, which are games and simulation. Things like dice rolls, card shuffling, random enemy behavior all need some element of randomness to be done effectively. Also, things like simulations and modeling, in this case more for serious things like weather, traffic, population growth, stock market fluctuations, also need some element of randomness in them. Also, things like randomized testing. For example, in some cases we test software using fuzzy testing, where we give the software random inputs and then check to see if those outputs are expected, if they match our expectations, or if it means that there could be bugs here if we're getting unexpected results. Also in other areas, there is a thing called A/B testing, where you assign users to different groups, an A group and a B group, and then you compare maybe two different designs of a website and see which the users like more or what made them click more on ads. And we need to randomly assign users to those categories. So again, being able to randomly assign things to different categories or groups would be another application of randomness in computer programming. We also have things like security and cryptography, like generating random tokens, such as random passwords, API keys, or session tokens, as well as things like encryption, where we need to have a true source of randomness to make things like cryptographic keys. And there's also things like data sampling, where we need a random selection of data points for surveys, experiments, machine learning models, as well as many other things. I'm sure you could think of many more examples as well. So now that we know a little bit about what randomness is and pseudo-random number generators, how do we actually make random numbers in Python? Well, Python has a module all about pseudo-random number generation, and that module is called random. But before we can use random, we need to import it, just like how we saw with the math module. And the way we import that is very similar. Instead of import math, we say import random. And then we'll have access to many of the random functions and methods from this module. And I have a table of some of them here. We'll go through a few. The first one is randint, and this takes two integer values, a and b, and it's going to return a random integer n such that a is less than equal to n and n is less than equal to b. So that means it's going to return a random number in the range between a and b, where a and b are both inclusive. We have an example on the side here where we're saying randint 510. In this case, just by chance, we get a 10 as the result. The next function, randrange, is very similar to randint. The only difference is the endpoint, the stop, is not inclusive. It's more similar to the range function. Next up is the random function. It takes no inputs, but it returns a random floating point number between 0 inclusive and up to, but not quite including, the number 1. So since this is a floating point number, it can have decimal places, so we could get anything between those two values, like 0.7, 0.65, 0.00001, or even the number 0, but not 1 because it's up to and not including 1. Next up is uniform, and this is basically the version of randint for floating point numbers. It takes an a value and a b value, and it's going to return the number n such that a is less than equal to n and n is less than equal to b. So that means that it's inclusive of those ranges a and b. Next up is the choice function. And this one's a bit more interesting than the other examples we've seen because it doesn't just return a random number. Instead, we give it a sequence, like a string, a list, or a tuple, and it returns an element from that sequence at random. So if we gave it, for example, the string hello world, it would return one character from that string at random. In the example we see on the screen right now, it's returning the letter D. The sample function is similar, except it returns a list of k elements. So we give it some sequence, for example, a string like hello world, and we give it a value k, which is how many elements to return at random from that sequence. Just make sure to note here that sample doesn't return a string. If we give it a string, it returns a list of characters. So we give it hello world and say return 5 characters. We don't get a new string. Instead, we get a list with each one of those characters being its own element. We'll talk more about lists and collections a little bit later in the course, so we'll probably come back to this one. The last function shown here is the shuffle function. What this does is it takes a mutable sequence and it shuffles all of the elements around in a new order. Now, one thing to keep in mind here is that even though strings are a sequence, they're not mutable. So that means we can't use a string with shuffle. But we can use something like a list, as shown in this example here, and you can see that it changes the order of that list. Now, the random module does have many more functions that are quite useful. However, these are probably the most common ones and the ones we'll see coming up in this course. Okay, let's take a look at an example. In this case, we want to write a Python program, and it's going to let the user input the number of sides on a dice. It's going to simulate that dice roll and then tell the user what face is facing up. So if we put in a 6, it's going to simulate rolling a dice that has 6 sides and thus tell us the value. If we put in a 20, it would simulate a dice roll with a dice that has 20 sides and tell us what the value is. So here's the program. We'll go through it in a second. But the important thing here is each time we run this, we could get a different result, even for the same inputs. So for example, if we ran it and we put a 6 in for a 6-sided dice, we might get 2 the first time we run it. But if we run it again and give the same input a 6, the next time we might get a 6 as an output. The reason why is we're importing that random module, and we're using the randin function to get a pseudo-randomly generated number. So let's see how this works. First, we have to import random because we need access to that random module so we can use randint. Next, all this code here is simply checking for errors in the user input. It's checking if the user input's invalid because it's not actually a decimal number. Maybe they input the word like duck. That doesn't make sense. Or it's checking if the number is less than or equal to 0. It doesn't really make sense to have a 0-sided die. If everything checks out, then we're going to run these lines. First, we're just converting the value input by the user to an integer so we can use it. And then here is where the interesting stuff happens. This is where we generate a random number. So we're using the randint function, and we're saying the lower bound is going to be a 1, and the upper bound is going to be equal to sides, however many sides there are on the dice. So if we input a 6, the random number is going to be between 1 and 6. And remember, randint is inclusive. So that means we could get 1s and 6s, just like we could get 2s, 3s, 4s, and so on. And then we simply output that random number to the user. So it's fairly straightforward when we're using that random module. Now let's make this a little bit more interesting. Instead of just rolling the dice once, how about we input the number of sides and then roll the dice 10 times to see what kind of results we get. So the program looks very similar. The only difference is we're adding this for loop here. So it says we're going to run it for 0 to 10, which means that the 0, the starting point, is inclusive. So we start off I equals 0, and we go up to, but not equal to 10. So it would be 0 all the way up to 9. So we'd run it once for 0, then 1, then 2, and so on. And in total, we'd run it 10 times. The other code is pretty much identical to the last example we saw, except we're just generating those random numbers in a loop now. So it's going to output 10 of them. So if we run this code, we would get 10 randomly generated numbers. And since we input 10 here, they would be between 1 and 10 inclusively. And what's really interesting is if we run this a second time, we would get 10 different random numbers between 1 and 10. And a third time, again, we get another set of 10 random numbers that's completely different. And this is what we mean sort of by pseudo-random. Even though these numbers aren't really random, there would be a way to predict them. We are, at least from the user's perspective, getting different output each time we run the program. And there doesn't seem to be any sort of repetition or correlation between the numbers we're getting. They appear to be random because they have the properties of random numbers. But we did mention before that PRNGs have a seed value that control that sequence of random numbers. And if we look back, each one of these has a different sequence. So what's going on here, and how do we control that seed value? Well, there is a seed involved even in Python's PRNG, and that does determine the order of random numbers we get from the randint function. And if we set that seed, we can make it so randint is always going to return the same numbers in the same order. Well, this might not be desirable when we're trying to simulate a dice roll, because it would mean we get the same dice roll each time. It could be useful when we're trying to debug our program, or if we desired some sort of reproducibility. And the way we set the seed in Python is with the seed function, which is part of the random module, so it would be random.seed. And we simply pass it a seed value. The seed value is going to be an integer value or none. If the value none is given, then the seed is set to the current system time. That's important because the current system time is useful because it's a number that's always changing. So every second, you're going to get a different seed value, which means every time you run that program, the seed's going to be different, and that means you get a different series of random numbers. But we could override that and give it a constant value that's always going to be the same. Let's see what that would look like. So let's take a look at an example where we set the seed. And this is actually the same example we just saw, where we're asking the user for the number of sides on a dice and then rolling that dice 10 times. Except now we're going to try to see what happens if we set the seed to 1,337 before we do those dice rolls. Here's the code, and it's exactly the same as what we just saw, except we added this one line here. And this sets the seed for the PRNG to 1,337. Now, every time we run it, we're going to get the same series of numbers. So in this case, we run it, we input 10 for a dice with 10 sides, and we get this series when we roll it. We get a 10, a 9, a 6, a 10, 10, so on. But if we were to run it a second time, we would now get the exact same numbers in the exact same order. Third time, once again, we get the same numbers in the same order because we set a specific seed, and that seed isn't changing now. Before it was changing to the current system time. So each time we ran it, we'd get a different seed, which meant different series of numbers. Now, in most cases, you probably don't want to do this. You shouldn't set the seed unless you're doing something where you want this reproducibility. For example, you're debugging the program. The reason why is this program's now kind of pointless. What's the point of having a program that rolls dice for you if it's always going to be the same side of the dice that's facing up? So make sure you only set the seed to something other than none if it makes sense for your use case. So far we've only seen examples where we generate a random number, either an integer using something like randint, or a floating point number using something like the uniform function. But how could we generate other values? Like maybe how could we generate random characters? Well, one thing we could do is take advantage of the choice function from the random module. Recall that that choice function returns a random element from a sequence, and strings are a type of sequence. So we could use random choice to return a random character from an existing string. I have a simple example here about how that could work. And the goal of this example is to return a random uppercase letter. The way this works is we first import the random module, and we do that because we want to use the choice function. And we pass to the choice function a string that contains all of the uppercase alphabetic letters. So A to Z, all in uppercase. And what choice does is it's going to take a look at that string and return a random character from that string. So if we ran this, the next line print would print out whatever that random character is. So it could be something like P, it could be something like Q, any of the letters are possible, but it's only going to return one. Let's take a look at a more realistic example. In this case, we're trying to make a random postal code. So we want to write a program that's going to return a postal code in the format of letter, digit, letter, digit, letter, digit, which is the real format for postal codes in Canada. And those letters have a certain set of letters they can be. It's not the full alphabet. For example, D's, I's, O's are all missing here. And the reason why they do this in real life is because those characters might be confused with another letter or digit. For example, O is often confused with 0, so it's not included. The digits in a postal code can be any digit between 0 and 9 inclusive. We have a solution here. What this is doing is first defining two constant strings. The first one is letters, and those contain all the valid letters we discussed. And then we have one for numbers with all the valid digits that can be in a postal code. Then what we're doing is we're building this postal code one letter or digit at a time. We start off by declaring rand code equal to a choice from letters. So it's going to pick a random letter from letters, and that will start us off. We then add to it with a random number from the numbers string, and then we add a letter, then a space, then another random number, then another random letter, and then a random number. Then we finally output that to the screen. So let's see what would happen if we ran this program. Well, first time we run it, maybe we get a result like this, which is a postal code that's S2T space 3R3. And because we are using a pseudorandom generator and we're not setting the seed, that means the next time we run it, the seed's going to update based on the system time, and we'll get a different result. So the second time we run it, we might get something like G5B 3L5. And then the third time, something else like L7K 5T5. Each time we run it, we get a different postal code. And again, this is doing it by just choosing random letters, numbers from these two strings, and then adding them together. Now I should mention the random.choice function also works on other sequences, such as lists and tuples. And we'll be talking a lot more about lists and tuples later in the course, but for now let's take a look at a really simple example. In this case, we have a list that has a bunch of different types of elements. It's got 1, 2, 3, the string cat, the string duck, and the floating point value 3.145. When we use this with choice, it's going to pick an element at random from there, which could be any one of these types or values. So for example, we might run this and get cat, and we might run it again and get 3.145. So choice is an extremely useful function that can be used on any kind of sequence. Now we're going to look at one last example before we're done this video, and that is going to be solving this problem here in Python, and we'll code this one together. So the problem is write a program that asks the user for 3 inputs: the number of dice to roll, the number of sides each die should have, and the number of times to roll all the dice together as one roll. So the idea here is the user's going to say how many sides each of our dice have, how many dice we have, and then how many times we have to roll all those dice at once. So we're going to take all the dice in our hand and roll them X number of times, over and over again. And each time we do that roll, we want to calculate the total value of the dice. So if we have 3 dice and we roll them and they all land on 1, the total would be 3. And we want to keep track of that sum. After we're done all of those dice rolls, we then want to display the average total of all the rolls. So let's see an example of what this output might look like. So here the user is inputting the number 3 first, which is how many dice to roll. So each time we roll, we're going to roll 3 dice. Then they input the number of sides on each dice. So each die is going to have 6 sides. Then lastly, they put in the number of times to roll all the dice. So we're going to roll all 3 2 times. Then we see the actual simulation of the roll. So it says roll 1, die 1 is 4, die 2 is 2, die 3 is 5, and the roll total is 11, which is just adding 4 plus 2 plus 5. Then we do roll number 2, and we say die 1 has a value of 4, 2 is 6, and 3 is 2, and the total is 12, which again is just adding those values together, 4 plus 6 plus 2. And at the end, it tells us the average of the rolls, which in this case would be 11 plus 12 divided by 2. So how would we actually code this? Well, let's switch over to PyCharm and give it a try. Okay, here we are in PyCharm, and we have one comment that describes the program we're trying to write. And since this is going to involve random numbers for those dice throws, the first thing we're going to do is import the random module. We're going to need that for things like randint. Next, the problem describes 3 different things we have to input from the user: the number of sides on each dice, number of dice, and the number of times to roll them. start with the number of dice. And we'll go input the number of dice to roll. And this does have to be an integer value, so we're going to convert it to an integer right here using the int function. This does mean that it's not going to accept really invalid input like duck, but we're not trying to focus on that right now. You can always go back and add more error checking later. Number of sides. Again, this is going to be an integer. We're just going to ask them how many sides on their dice. And lastly, we want to know how many times they're going to roll these dice. Okay, so we have our inputs now, and now we're going to probably need a loop structure because we're doing something repeatedly. We're doing something a set number of times. And we'll start with the number of times to roll the dice, which is stored in num rolls, and we know we're going to have to run the loop that many times. So we'll do a for loop that's good for running so many number of times when we combine it with range. For I in range. And we want num rolls. So that's going to run this loop from I equal to 0 all the way up to num rolls -1, but in total, that's num rolls times. So this loop is going to represent how many times we roll all the dice. So we have all the dice in our hand and we roll them. So let's say we do that 10 times, put them all in our hand and we roll them 10 times. But we need another loop that's going to track those individual dice each. And we're going to have to run that second loop for each individual die to roll each one, because we don't know how many there's going to be. So we can't just hard code it and roll 3 dice because the user could input like 20. So we're going to have a second loop that's going to run once for each die. So we have the outer loop that runs once for the whole roll, and we have an inner loop that determines what face was on each die. And we want a little bit of text just to make everything clear. So we want the user to understand what's going on. This also will help with debugging of it. So we'll call this roll number. And we'll say I. So it's going to print out roll number, and then it's going to actually put whatever the value of I is. So next we'll go print. Just some dashes to separate it. And then we'll actually print out what the dice were in each roll. So first we have to figure out the face of the dice. And this is where we're going to use random.randint. Randint takes 2 values, the low end of the range and the high end of the range, and they're both inclusive. So in this case, the lowest one is always going to be a 1, because we have to have a dice that has at least 1 side or more. And it's going to go up to the number of sides. So this should give us that random roll. And now we want to print it out so the user knows what it was. So we're going to say dice, or I should say die rather. And we're going to give the number of the die. So K here represents which dice it is, or die that it is that we rolled. And we're going to want to say what its value is. In this case, it's going to be face. But the other thing we're trying to do is keep track of the total for a specific roll as well as the total overall. So we're going to need some variables to store that. So for the specific roll, we can define it in this loop because we want to reset it each inner loop, because each roll is going to have a different total. We'll call this roll total. And we're going to give that the value 0. So every time we do the outer loop, it's going to reset total to 0. And in here, we're going to keep track of it by adding whatever the face is to it. So when we have a handful of dice and we roll them, we then add up all of the faces to get the total for that roll. And we can print that out here. We're outside the loop. So this is going to happen after we determine the face for each dice. We could say roll total is, And we'll put it here. So that gives us the number of dice, or the total of the faces of the dice for a specific roll. But the other thing we need to do is keep track of the overall total so we can take an average at the end. So we're going to have to define that over here, outside of the main loop. And we'll start that at 0. So where we place these definitions is very important. When it's outside of the outer loop, it means we're going to start it off at 0, and then it's always going to be added to. We're not going to reset overall total. Roll total, on the other hand, is inside this outer loop, which means each time the outer loop runs, roll total is being reset to 0. And what we're going to do with that is we're going to add the roll total to the overall total. And this will allow us to keep track of the overall sum of all the dice faces, so we can compute an average at the end. So let's see, we're running the loop, we're saying the roll number, we're printing out a little dashes just to be a nice separator. And down here, we are then going through, figuring out what the face of each die is in that roll, printing out the value, and then we print out the total for that roll, we add it to our overall total, and we restart the loop again to get the next total. Now, one thing we can do just to make the output look a little bit nicer is put a line break here, so there's a space between each roll. Now, at the end, we want to compute the average. And that's simply equal to the overall total divided by the number of rolls. And we want to output that to the user. So let's see what happens if we try running this. Number of dice to roll. We'll say we're going to roll 3 dice. We'll go with classic 6-sided dice. And we'll say we'll run it 2 times. Let's see what we got here. So we have roll 0. We have 3 dice. It's a 1, 4, and 4. It says the roll total is 9. That looks good to me. Our second roll, we're saying dice 0 was 5. Dice 1 had a 2. Dice 4 had a 4. Dice 2 had a 4, and the roll total was 11. And then we get the average was 10. And the average is indeed 10. Now there is a few quality of life things we could do, like these counts are starting at 0. Maybe we want to make it a little more accessible to regular people, and we want to start these at 1. So there's a few ways we could do that. We could change the range, so it starts at 1 and runs up to numerals, or we could simply add 1 over here. And add 1 here. So this doesn't change at all how our code actually works in terms of the calculations it's doing. It's just changing the number that's going to be output to the user. And this just adds 1 to each so that these numbers will be higher. So when we run this again, we say, let's say this time we're going to run 2 dice. And there will be, let's go with 10-sided dice. And let's roll them 3 times. So now we can see that the numbers start at 1. Instead of starting at 0, which is a little bit nicer, but it doesn't change how the code works. They're still going to roll the random numbers. We're still going to calculate the roll totals, and then we're going to find the average. We also add a line break here to make it a little bit cleaner. Let's try something big. Number of dice to roll. Let's do a 10. Let's just do 2-sided dice, and we'll run it 4 times. So we're going to get a lot more output now. We can see roll 1, there's our 10 dice. Roll 2, there's our 10 dice. And remember, we're only getting 1s and 2s because we said these are 2-sided dice. I guess that'd be more like a coin. And the average roll total was 15. So that seems to be working. There are more things we could do to improve this. For example, we could add some error checking. Make sure that these numbers make sense. It won't really make sense if the number of dice was 0 or negative. Same thing with number of sides. We could do some error checking to see the number of sides was 0 or less. And same thing with number of rolls. We probably want to make sure that's greater than 0 for it to make sense. Now, one last thing we'll look at is I said there was 2 different ways we could do this to make the numbers start at 1. So let's take a look at the other way. So instead of adding 1 here, we could change how our ranges work. Remember, the range can either be a single value, which is just the stop, which is exclusive, and that means it starts at 0 and goes up to that value. Alternatively, we can give it a starting point that's inclusive, so 1 in this case, and then it will run up to the stop point exclusive. So to make that inclusive, we'd add 1 here. So if we want to make sure I and K actually started at 1, rather than just changing how they're displayed to the user, we could change the loops to look more like this. So let's try that again. Roll 3 dice. This time, make them 4-sided, and we'll run them 3 times. And you can see that we have the numbers still starting at 1. So like I said in previous videos, there's always more than one way to write the same thing. In this case, we're changing it so I now starts at 1, rather than changing how I is displayed by adding it to it before printing it out. So I think that's pretty much everything we want to do in this program. You could add that error checking like I said, but let's head back to the slides. And we're back to the slides. And for those of you following along in the PDF, there is a copy of the solution here that I wrote earlier, and we can also find that on our learning management system. It's pretty much the same, just some of the comments, some of the strings, and some of the variable names might be slightly different. That's all I have for you in this video on randomness. I highly recommend trying these examples out, as well as playing around with them. A good practice problem might be trying to make a program that flips a coin and says either heads or tails. Thank you for watching, and have a great day.